Right now, you are being bombarded by deadly radiation from space. But you are not dying. Why? Because deep beneath your feet, 3,000 kilometers down, a churning ocean of molten iron is spinning at incredible speeds, generating an invisible force field that's literally keeping you alive. This is the story of Earth's magnetic field, our planet's greatest unsung hero. To understand how Earth protects us, we need to go to one of the most extreme places in the solar system, our planet's core. Temperatures reaching 6,000 degrees Celsius, hotter than the surface of the sun, with pressure 3.5 million times greater than what you are experiencing right now. The Earth's core isn't solid rock like the ground beneath us. It's a two-part system that works like a massive generator. The inner core is a solid ball of iron and nickel, about the size of the moon, spinning independently from the rest of the planet. Surrounding it is the outer core, a turbulent sea of liquid metal, constantly in motion. This liquid iron doesn't just sit there peacefully. It's in constant violent motion, driven by the heat radiating from the inner core and the cooling effects at its outer boundary. These convection currents create something remarkable. They turn our entire planet into a giant electromagnet. This process is called the geodynamo, and it's been running continuously for over 3.4 billion years. The magnetic field generated by our core extends far beyond Earth's surface, creating what scientists call the magnetosphere, an invisible bubble that stretches about 65,000 kilometers into space on the side facing the sun. This isn't just empty space we are talking about. It's a dynamic, constantly shifting protective barrier. Think of Earth's magnetic field like a cosmic deflector shield. The field lines emerge from near the South Pole, arc through space and re-enter near the North Pole, creating a dipolar structure similar to a bar magnet. The most beautiful evidence of this magnetic shield is something you might have seen in photos or videos: the aurora borealis and aurora australis, the northern and southern lights. These spectacular light shows occur when charged particles from space interact with our magnetic field, getting funneled through the poles where they collide with atoms in our atmosphere, creating those ethereal green, blue and red curtains of light. But what exactly is our magnetic field protecting us from? Space isn't the peaceful, empty void it might appear to be. It's filled with deadly radiation and high-energy particles that would sterilize our planet if they reached the surface unimpeded. The primary threat comes from cosmic rays, high-energy particles traveling at nearly the speed of light, originating from exploding stars, black holes, and other violent cosmic events. These particles carry so much energy that they can damage DNA, cause cancer, and disrupt electronic systems. Without protection, cosmic rays would make complex life impossible on Earth's surface. Even more immediate is the solar wind, a constant stream of charged particles flowing from our sun at speeds of 400 to 800 kilometers per second. The sun also periodically unleashes solar flares and coronal mass ejections. Our magnetosphere acts like a cosmic snowplow, deflecting most of these particles around our planet. The magnetic field lines guide the charged particles away from Earth's equatorial regions, where most of our population lives, and channel some of them toward the polar regions where they create the auroras. The implications of our magnetic field go far beyond just protecting us from radiation. Mars once had a magnetic field, but it shut down about 4 billion years ago when its core cooled and solidified. Without magnetic protection, the solar wind has been slowly stripping away Mars's atmosphere for billions of years, leaving behind the thin, cold atmosphere we see today. Earth's magnetic field doesn't just deflect harmful radiation, it also helps preserve our atmosphere. Charged particles from the solar wind would otherwise interact directly with our atmosphere, gradually stripping it away atom by atom. Over geological timescales, this process would leave Earth as dry and airless as Mars. The magnetic field also protects the ozone layer, which provides additional shielding from harmful ultraviolet radiation. Without magnetic protection, increased cosmic ray bombardment would destroy ozone molecules, exposing the surface to sterilizing UV radiation. Consider this. Every breath you take, every drop of water you drink, and every moment you are alive is possible because of this churning molten iron 3000 kilometers beneath your feet. The magnetic field has been the silent guardian of life on Earth for billions of years, allowing evolution to proceed and complex ecosystems to develop. What is a little worrying is that Earth's magnetic field isn't constant. It fluctuates in strength and direction, and periodically it even flips completely. Magnetic north becomes magnetic south. These magnetic reversals happen roughly every 200,000 to 300,000 years. But the last one occurred 780,000 years ago. We are overdue. During a magnetic reversal, which can take hundreds of thousands of years to complete, the field strength can drop to just 10% of its normal intensity. During these periods, our protection from cosmic radiation is severely compromised. Currently, the magnetic North Pole is racing across the Arctic at about 50 kilometers per hour, and the overall field strength has decreased by about 10% over the past 150 years. While this doesn't necessarily mean a reversal is imminent, it reminds us that our protective shield is dynamic and potentially vulnerable. The next time you look up at the night sky, remember that you are not just seeing distant stars and planets. You are looking through an invisible force field generated by our planet's molten heart. Our existence depends on so many precise conditions: the right distance from the sun, the right atmospheric composition, liquid water, and crucially, a magnetic field strong enough to deflect the universe's constant assault of deadly radiation.